Okay, the second test we need is called Friedman test. And actually this is a very powerful tool, so it gives us two very important information. The first one is through this test we could figure out whether the given ciphertext is monoalphabetic or polyalphabetic. And the second one is if it's a polyalphabetic, then it could suggest some kind of length of the keyword for that ciphertext. Okay, and to do this test, actually using the index of coincidence. From now on, you are going to call it IC, and it actually tells us the probability of the chance to pick the same letter if you choose two characters out of this ciphertext. So the statement is like this: the index of coincidence, IC, simply is the probability of that the randomly chosen two letters are equal, and by that we could figure out whether the given ciphertext is monoalphabetic or polyalphabetic. Okay, so from now on, to compute the IC, let's say number n is number of letters in the text, and n1 the total number of letters in the text, and n1 is number of a's, the letter a's in the text, n2 is number of b's in the text, so n26 is number of z's in the given ciphertext. Then clearly the probability of getting two a's if you choose two random characters out of this ciphertext is going to be calculated by, out of n letters we choose two randomly, right? So that's the kind of cases, all the possible cases, and if both of them are two a's, then there are n kind of 1, right? If it's a, right, then n1, and we choose two out of that. Okay, so that's gonna be the choice, the cases that we choose a's. So if you change I to 2, then this will giving us the chance to get two b's by that, right? So just keep doing this way, right? So after calculated, we got this formula to getting the probability to pick the same letters for each I. So the IC is going to be the probability of getting same letters for these randomly chosen ones, for no matter what that letters are, right? It could be A's or B's. So we have to add all these possible cases, the probabilities, right? So summation of these formulas when I1 from 26. And good thing about this formula is just assuming our ciphertext is long enough. Of course, in practical way, even the individual ciphertext is short, but if you're just collecting this ciphertext from the enemy, then you can have this long enough whole ciphertext. So if we increase the size of the ciphertext, meaning is n is going to be going larger and larger, then n, if you compare n and n-1, it's very close enough for this formula. So we can just use n instead of n-1, and even for n sub I has the similar situation, right? You might have many a's and many b's in there, right? So we can just substitute n and n sub I for this part. Then our formula for IC can be shrink down this much simpler formation. So IC has approximation of this result, summation of ni over n squared when I is from 1 to 26.